Hello everyone, I am Angeline Kaye from APM 11 YA-9, and today I'm going to help you understand the probability distribution.
Good day everyone, I am Angeline Kaye and today we are going to talk about the probability distribution or conceptualization. When we say probability distribution of a discrete variable, here we are going to see the probability of every and each value of a random variable. When it comes to discrete variable, there are two properties. First is the probability of each outcome is from 0 to 10, and then the sum of all the probabilities of the RV is equals to 1 or 100%. When we are going to calculate what's inside of the column right here, we must remember that it should always equals to 1, always 1, no less, no more. Let's see. And the px 0.1, 0.3, 0.4, and 0.2. Now, get your calculus and let's calculate this one. Okay, 0.1 plus 0.3 plus 0.4 plus 0.2 is equals to, let's see, it's equals to 1. Good job. Now let's go to our next example for us to truly understand the probability of distribution of a discrete random variable. A mother is giving birth to a twin. Let X denotes the numbers of girls. X, 0, 1, and 2. Here is the framework. You can see boy, 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 girl, girl, boy, and girl, girl. Now in X, there are the nodes of 0, 1, and 2. Px is equals to and 0. For us to locate it, let's calculate it or let's deepen it more. So 0, as you can see in the example, how many, the question in here is how many in this framework right here that doesn't have a girl or 0 girl. As you can see, there is 1, which is the boy boy, as you can see, and that will be 1. And then the number or the denominator right here is what we call the total of the denotation right here. Okay, so and the next, how many how many twins consist of one girl? As you can see here, the boy and girl, that is 1, and then girl and boy, that is 2, that is 2 out of 4. And then how many of them consist of 2 girls? As you can see, there is only 1, so that will be 1/4. And the total of that is 4 over 4. Or we also can reduce it and turn it to 1. So that means our table right here is correct. Now let's go to the next example. If 3 coins are tossed, if X is a random variable for the number of heads. Okay, here are the possible outcomes. We put it in a table for us to be easily locate because discrete means table. So head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. So the value of x is for the heads or 3 heads is 3. The HHT or the head tails consists of 2. HTH or head tail head is also 2. HTT or head tail tail consists of 1. THH tail head have 2. THT or tail head tail had 1. TTH or tail head have 1. Tail is 0. So if we put it in a table right here in the example, consists of 0 head, there is 1, which is this which is this, the H here, the the TTT that consists of 1, so that will be 1 out of, 1 out of 8. And then what in the possible outcome, or how many in our possible outcomes consists of 1 head? Let's count. 1 head. Okay, this one consists of 1 head, and then this one also consists of 1 head. And here too, that means 1 plus 1 plus 1 is equals to 3. So that is 3. Oh, sorry. So that is equals to 3 out of 8. Next, what or how many possible outcomes consist of 3? Consists of 2 heads. So let's count. Here 2, also here, and also here. That means 3. Oh, sorry, no, my fault. It will be equals to, let's see, 3 out of 8. And how many of them consist of 3 head? 1. So that will be 1 out of 8. And if we add them together or sum them up, that will be 1 plus 3 is equals to 4, plus 3 is equals to 7, plus 1 is equals to what? 8 over 8, or equals to 1. That's it. Now let's go to our next example. Construct a probability distribution for rolling wheel that consists of number 1, 2, 3, 4, 5, and 6. As you can see, we put the 1 to 6 numbers in the X. Okay, so this is the easy one. We can just easily say it that the number that consists 1 is only 1. The number that consists 2 is only 1. The only number that exists in 3 is only 1, 4, 1, 5, 1, 6, 1. And 6 is their numerator because it is the total of the X. So that will be 1 plus 1 plus 1 plus 1 plus 1 plus 1 is equals to 6. 6 out of 6 equals to 1. Now that we fully understand it, because this is an easy subject, easy topic, I say, let's have a simple quiz, and you can pause it while you are taking notes in your notebook, in your laptop, and I will post the answer right after you copy the quiz. So here's one. A police officer is interested in the number of times the average racist will ring their phone during a 12-hour shift. For a random sample of 50 people, the following information was obtained. Let X the number of the times a racist rings the phone during a 12-hour shift for this exercise. Let X denote 0, 1, 2, 3, 4, 5. Then the PX is the probability that X takes values on X. The next quiz is Jessie has a classes 3 days a week. She attends classes 3 days a week 80% of the time, 2 days 15% of the time, 1 day 4% of the time, and numbered days 1% of the time. Suppose 1 week is A. Let X equals the number of days Nancy blank. B. X takes on what values randomly selected. C is the table of it. Is construct a probability distribution for the numbers on the pie.
And to end this video, I'm going to leave you with a message by Andrew Wiles that just because we can find solution doesn't mean that there isn't one.